Simplify radical expressions involving multiplication. So let's look at number 6. Here we have a number multiplied by some radical expression, so 2 times the square root of 20 times the square root of 20. So when you have a problem like this, my first suggestion to you is that you want to break down and get the prime factorization of every radicand in the problem. So if we take apart 20 and find the prime factorization of 20, that would be 2 times 2 times 5 times, and then over here we're going to have, this is just the square root of 20 again, so it's 2 times 2 times 5. So I've broken this down. And now, when I go to multiply these, all I have to do is multiply the coefficients, the numbers on the outside. So here I have a 2 on the outside. Over here, there's nothing. I can think of that as a 1. So I take 2 times 1 and 2. That gives me my coefficient. And now, what I'm going to do here, there's a couple things I'm going to do at once. So kind of watch closely here. Normally, all I'm really doing here is taking 20 times 20, and so this is going to be 400. But what's going to happen is we're going to need to simplify that radical. We don't want to leave it as just the square root of 400. We want to simplify it. So again, really all I'm doing is I multiply the coefficients and then I multiply the radicands, and that gives me the first part of my answer. But since I'm going to want to simplify this, go ahead and think of multiplying all of these together, and I'm just going to rewrite to get everything next to each other. It's 2 times 2 times 2 times 2 times 5 times 5. So notice that just contains everything that was under there. We had 4 2's and 2 5's. And so now I want to simplify this as much as I can, and it's simplifying radicals just like we did before. So I can simplify there, there, and there, and so I can pull all of these to the outside, remembering that when I do, these two are going to compress into 1, if you will, because we're taking the square root of 2 squared. So I would get this 2 times the square root of 2 squared, which is 2 times 2 times 5. I don't have anything left under the radical, so that all just goes away. And so I'm left with an answer of there's 10, 20, 40. And so that's the simplified version of this. So again, when I'm multiplying these, all I really did was I multiplied the coefficients, and then I multiplied the radicands, and then simplified the resulting one. So I'm going to show you 2 other quick ways you could have done this. You could have said that this was 2 times the square root of 20 times the square root of 20. Multiply coefficients gives you 2. Multiply the radicands, that gives you 400. And then simplify the square root of 400, which happens to be 20, which would give you this. So that's one alternate way of doing this. Here's another alternate way of doing this. When we multiply the square root of 20 times the square root of 20, we should kind of realize that that's the same thing as the square root of 20 squared. The square root and the squared operations are inverses of each other, so they cancel each other out. So that leaves me with just a 20 there. So it would kind of look like this. You get 2 times the square root of 20 times the square root of 20 means 2 times the square root of 20 squared, which means 2 times 20, which is 40. Now, if none of that made sense, you can stick with just this method here, which is how I'm going to do all the rest of these, and it'll get you the right answer every time. All right, let's look at number 7. We've got negative 3 times the square root of 12 times negative 5 times the square root of 15. And as I said before, I'm going to get the prime factorization of each of those. For 12, it's 2 times 2 times 3 times negative 5, and then 15 is 3 times 5. Now I multiply my coefficients. Negative 3 times negative 5 is positive 15. And I'm going to list out all of my factors here. I have 2 2's, 2 3's, and a 5. any pair can be pulled to the outside. So I'm going to have 15 times 2 times 3 times the square root of 5. 15 times 2 would be 30. 30 times 3 is 90. So this would be 90 times the square root of 5. All right, and when we look at problems like 8 and 9, it seems to be more confusing, but it's really just two of these problems put together, essentially. So let's take a look at it. We have 3 root 5 times root 5 plus root 3. And so I have two problems here. I have 3 times the square root of 5 times the square root of 5 plus 3 times the square root of 5 times the square root of 3. And so I'm going to just go ahead and simplify these. 3 times 1 is 3 for my coefficient times the square root of 5 times 5 plus 3 times 1 times the square root of 3 times 5. And as I continue to simplify this, I'll find that this can be pulled to the outside and just becomes 15, 3 times 5. And here, this can't be simplified. And so my answer is 15 plus 3 times the square root of 15. So again, I'm just doing two of those problems. This times this, which is very, very similar to number 6. And this times this, very, very similar to 6 and 7 again. And it's just the distributive property, adding through that. So let's take a look at number 9. Which is just like that. I have the advantage of being able to see what this problem is, so I'll just copy it down here for you. And now we go through and do the same thing. We're going to distribute this throughout both sides. So for this first one, I would take 2 times negative 5, which is negative 10, times the square root of 15 times 5. 15 is 3 times 5. Times 5. Alright, and now I do 2 times 1, which is 2. 15 is still 3 times 5, but now we're multiplying with a 2, so that's 2 times 3 times 5. This one can be simplified a bit. I can bring this 5 to the outside, and so I would get negative 50 root 3 plus, here there's nothing that can be brought to the outside, so it's plus 2 times the square root of 30, and now we have ourselves a simplified problem.